All right, next we want to determine whether A through C are true and give a counter example. So we're going to be looking at some properties. It says A, for linear functions, the slope of any secant line is always equal to the slope of a tangent line. Okay, so that would be true for a linear function. So when you draw a straight line, the slope of any 2 points is going to be the same as the slope of a tangent line. And so that would be true. A linear function has the same slope everywhere because it's a constant rate of change. So the average rate of growth is always equal to the instantaneous rate of growth. So that would be true when it's linear, only when it's linear. B, the slope of the secant line passing through the points P and Q is less than the slope of the tangent line at P. Okay, so we don't even know what the function looks like. We could pretty much come up with an example that would make that false, depending on if the slope is increasing or decreasing and how we draw it. So this is not going to be true every time. So we'll say the statement is false and we'll pick the correct example. So we have two of them. It says B, the statement is false if the slope of any secant line is always equal to the slope of the tangent line. That will be the case as we take the limit. A says the statement is false. Consider the graph of the parabola x squared. The slope of the secant line passing through the points -2, 4, and 2, 4 is 0, which is not less than the negative slope of the tangent line at -2, 4. So you don't have to work it out, but it's explaining that if you were to do it with this parabola and choose those points, you can use those 2 points to get the slope of the tangent line, which is 0, and that is not less than the slope of the tangent line, which would be negative if you just do it at that point. So this one is the one that describes why that is false. And C, it says consider the graph of the parabola f of x is equal to x squared, and this is for x is greater than 0 and h is greater than 0. The secant line through x f of x and x plus h and f x plus h always has a greater slope than the tangent line at x f of x. And again, this is similar to example B. That is not going to be true for every case. Well, we're thinking on the plus side. So let me look at this again. So the graph of the parabola here, the secant line through these 2 points always has a greater slope than the tangent line at x f of x. Okay, so let me show you what this is saying. So I would say yes, that is true. I'm sorry. Minimize that. So when you do a parabola, as you go to the right, this thing gets steeper and steeper. Okay, so the slope is getting steeper. And so if we pick some point, we can just call it x, and some other point h. Okay, the slope as I go from here to here, okay, is positive. But if I were to go and just add, and the further I go up the line, the steeper the slope is going to be. Okay, so as I go farther to the right, since I'm only focusing on the positive, they're greater than 0. It is going to be steeper. Like the secant line, if I'm doing 2 points, is going to be steeper than if I just go back to this point x. And that's what it's trying to say. It says, make sure I'm reading this correctly. Consider this parabola, the secant line through x and f of x, and then x plus h, so whatever h is, if I go a little bit further, always has a greater slope than the tangent line at x, so the smaller point. So yes, so if I just did the tangent line to this point versus at this point to there, it will have a the secant line will have a greater slope. So that statement will be true. Since the slope x squared is increasing, the average rate of change on the interval x to x plus h is going to be greater than the instantaneous rate of change at x. So that one looks like it describes exactly what's going on.